In this video, I would like to do some more examples with rational exponents. So in the examples here, we're going to transfer from the rational to the radical form in this case. So as a reminder, remember that when you have a radical or a rational expression you're trying to change into a radical expression, that means that the power that you're looking at is a fraction. So when you have that fraction exponent here, the numerator or the top number works as a regular exponent, and the denominator or that bottom number works as your radical. So that tells you which kind of radical or root you have. So for this one here, I'm looking at a fourth root of x to the first power, which is just the fourth root of x. In the second example here, I see the denominator is a 6. So this is a sixth root of 0 to the first power, which is the sixth root of 0. And the sixth root of 0 is also just going to be 0. So that one we actually can simplify further. For this one, I have the fourth root. So the fourth root of 81 x to the 8th to the first power. Again, that first power is not going to do anything right now. So when your numerator is a 1, it really isn't going to make a difference here. It is technically a first power. And then now what I can do is I can separate this and break this down. So here I'm going to do the fourth root of 81 and then the fourth root of x to the 8th. Now, the fourth root of 81 is going to be 3 because 3 times 3 is 9, times 3 is 27, times 3 is 81. Oops, 3. And then here, remember, what we're going to do is we're going to do that division. So it's going to be 8 to the x over 4, and that is going to go ahead and simplify 3x to the second power here. Now, not to skip over this example, we do see another one here. Notice that the 1/3 is only on the y. In this example, the whole thing was in parentheses, so the whole thing was part of the root. Here, it's just the y. So what happens is you actually have the 5 kind of hanging out, and this is being multiplied by a cubed root of y to the first power, or again, we don't really need that first power, just the cubed root of y. So you do want to be careful which part of the problem is that exponent related to. Is it in parentheses, so the whole thing is affected, or is it just a particular piece? Now, in the next few examples, we're doing the same thing, but notice that my numerator is now not going to be a 3. Sorry, not going to be a 1. It's going to be a 3 this time, or a 2 this time, etc. So we are mixing up a little bit, but it's the same exact process. The other thing I want you guys to recognize between E and F is that in this case, just the 16 is to the 3/4 power. That negative is just kind of hanging out outside, and it's just going to come down and tag along. That's different than over here where I have parentheses. So in this case, that negative is part of the power because it's in parentheses. So here the negative just comes down. I have the fourth root of 16 to the 3rd power. Now, the interesting thing with roots and powers is that they are basically equal on the food chain, so to say, and they're interchangeable. So you can write it like this, or you can write it like this, and do the 3rd power afterwards. And we usually go back and forth depending on what's easier to simplify. Now, in this particular case, I know that the fourth root of 16 is 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So for me, this form is easier because I can do that fourth root of 16 in my head. And then I'm just dealing with 2 to the 3rd after that, which is 8. So my answer here is -8. Now you could do it the other way though. So if I went in and I looked at my calculator here, if I did 16 to the 3rd power, so 16 times itself 3 times, I get 4,096. Now, the nice thing here, and what I recommend on your calculator, This one, it doesn't have a fourth root key. It does have a root key here, but it's often easier to actually use the exponent form on your calculator. So if I'm trying to figure out, well, okay, I just did 16, let's see, to the third power, and I want to find out what that root is, I may want to go ahead and do it as an exponent. So a fourth root would be a 1/4 power, right? I could go back and forth between the two forms. So I could go ahead and use my exponent key here. I'm probably going to put in parentheses so I don't mess up that fraction, and hit the equal sign. And then I could see I do get that same answer of 8. So your calculator can handle rational exponents as long as you remember to put it in parentheses if it's needed. Some calculators, you may not need parentheses, like this one here, the graphing app calculator. So if we had, what was it, 4096, I think, if I want to raise that to the 1/4 power, my calculator here automatically moves the exponent up. So I don't need parentheses, but a lot of them you will. So this is another nice feature to kind of play around with at home. Try some examples that you know the answer to and see if you get the right result. Now, it can even handle powers like this, which is really cool. If I do 16 to the 3/4 power and hit enter, I get the answer of 8. And then I'll just tack the negative on at the end. So this is a great way to check your work as well. All right, so you can always use those rational powers on your calculator. And then for this one here, I'm noticing that the negative is in the root. So I have the cubed root of -27 squared, or I have the cubed root of -27 squared. It doesn't matter which way you write it. They're both correct, and you can get the same answer both ways. Usually one is easier than the other. So for me, in this case, this one is much easier because I know the cube root of -27 is -3. So I can do that one because it's a cube that I'm familiar with. And then -3 squared is 9. But of course, you can always check this work on your own or and on your calculator too. So it's a great idea to get used to kind of checking out those answers. And again, just making sure that you have the correct result there. All right, a couple more here. So again, I have 3/2. The whole thing is in parentheses, so the whole thing is part of the power. So I'm using a square root of 1/9, all cubed. Again, or the square root of 1/9, all cubed. So choose the one that's easier for you. This one's much easier for me because I can write this as a square root of 1 over the square root of 9. Square root of 1 is 1, and square root of 9 is 3. And then when I cube it, I get 1 over 27. Now you could definitely do it this way as well, but I would definitely need my calculator to help me with that 9 cubed and then taking the square root afterwards. So again, either way is fine. Just pick the one that seems to be easier for you. For this example, again, I see parentheses. So the whole thing is part of this power. This is a 5th root, 4x minus 1, all cubed. Or I could technically write it like this. Like that. They're both correct. In this case, I probably like the first form better, just a little bit cleaner looking, but there's really nothing I can do here. So I'm not going to cube this out. Nothing is going to cancel and help me anyway. So this actually would be the final result. For these two examples here, I wanted to bring in some negative powers and remind you that we can still use negative powers here too. And don't forget that is a flipping action. So you want to actually do that first. So this is going to flip the whole thing to the denominator. And once I flip it, I do get that positive 2/3. And then now I can go ahead and work that root. You may want to even just do that off to the side. So that would be the cubed root of -27 all squared. The cubed root of -27 is -3, and -3 squared is 9. So this actually just becomes 1 over 9 here. For this one as well, I see a negative exponent. So the first thing I'm going to do is rewrite this and flip it. So 1 over 9 to the 3/2. Again, I'm going to go ahead and do that root. You don't have to, but you may want to do it off to the side. So this is a square root of 9 cubed, or the square root of 9 cubed. Again, I tend to like this form in most cases. Square root of 9 is 3, and then 3 cubed is going to be 27. So this right here is going to be 1 over 27. Now, we really like rational exponents as well. One, because they do work with all the rules we have for exponents. So notice like a negative exponent still means to flip, right? So it still holds all of those exponent rules that you already know can be applied to rational exponents, which is really great. And they also work really nicely with our calculators too. So our technology is programmed to work really well with rational exponents. So there are a lot of advantages to this form. And it's good to be able to go back and forth between the root form and then also the rational form. So it's key. Some cases the root is much more helpful. Other cases the rational exponent form is much more helpful. So we do want to be able to go back and forth between the two forms.